what I need you to do is I need you to think about what linear and quadratic means. That's what this lesson is about. Now, how do we know the difference? So if we were taking a look at the graph, if we were looking at something that is linear, right? A linear forms something that is nothing more than a straight line. Now, with that straight line, you have things like the y-intercept, which is known as the b variable, and the slope of the line, otherwise known as the rate, which is the m value in our equation. Now, let's discuss what the equations are. The equation for the line is something that says that all the variables are power 1. Now, here's an example. This is the basic example, y equals mx plus b. When we go and look for the regression, we literally just put in a table of values, and the regression gives us the m and the b value, and then we can state what the equation is. So here's an example of an equation. Y is equal to 100x plus 4. The rate, 100, always attaches to the x, and the 4 is what our starting value is. Now, when we talk about quadratics, we have something that's a little different. So, when we talk about a quadratic equation or quadratic formula, we're talking about something that looks like a parabola. And these are what parabolas look like. So we have a parabola that opens up and a parabola that opens down. This parabola here has a minimum, and this parabola here has a maximum. We also have a vertex for both. And we also have an axis of symmetry for both. Now, when we talk about quadratics, a quadratic equation, we're literally talking about one variable that is being squared on the equation. And here's the basic equation. You could have one where it's y equals x squared, or another one that looks like this. The basic equation for the regression is y equals a x minus h squared plus k. So when we go and create a table of values, we get our a value, we get our h value, and we get our k value, and all we do is restate the equation for the regression. So now on to the description in words of what's going on. When we talk about something that is linear, we say that something is constant, and when we're talking about its constant, we're talking about the constant rate of change. So it either continues to go up in a straight line, or it continues to go down in a straight line. Now, when we talk about a quadratic function, we're talking about quadratic functions where the direction changes, where there are many changes in direction, right? And basically, that looks like what a parabola is. Okay, now let's move on to a comparison between the two. What's the difference between linear and nonlinear? So here's the thing. When we have the two, one is a straight line and the other is not. When we're talking about a linear equation and a quadratic equation, there are two things. Let's talk about the equations. The first thing is the equation for the linear is y equals mx plus b. Now, for the quadratic, you have y equals a x minus squared, x minus h squared plus k. Now, when we talk about linear, we're talking about a constant rate of change. When we talk about the quadratic, there are many rates of change. That's why it ends up being curved. When we take a look at this, the next part that we have to understand about the linear is that the first differences are the same, therefore it's linear. But when we have a quadratic, it's the second differences that are the same. Your homework is to make sure that you complete page 11 in your booklets. get it done, and then I want you to do the flipped lesson for the day, which is the second lesson, which deals with triangles.